flight trajectories.
I'm afraid that's as far as I can go in German. I do apologise. I also apologise for not being Florin. Those of you who have the paper programme will still see his name, and he passes on his apologies for not being able to make it due to other constraints from which he could not escape. I'm here to give you a high-level view of what SESAR means in this world of noise abatement. I'm going to take a little bit of a step back at the beginning and introduce the general context of the SESAR programme. Some of you, of course, will be very familiar. Others, I think this will be a little bit more new for you. So SESAR is the research and development programme that forms part of the Single European Sky initiative in the EU. It is a research and development programme, but it is one that engages with the industry, with the users, with the airlines, with the ANSPs, in order to deliver solutions that deliver specific performance benefits to the ATM system. And you see a very generic vision slide here, but it's important. It's important to understand that we're looking at improvements, step improvements in the ATM system that deliver across the full set of performance targets that we have, covering issues such as capacity, cost efficiency, environment, safety, security. So we have this broad view across these specific performance targets. And certain activities that we have will target particular performance aspects. But what's also important is that we maintain the view on the other performance aspects, and similar to our previous speakers, this means if we have a project that's targeting an improvement in capacity, for example, we're still looking at the impact that has on safety, environment, security, etc. Similarly, for the environmental aspects that include the emissions and, of course, the noise impact, the specific activities that we have focusing on these also need to take into account the constraints coming from the other performance aspects. But taking this a whole vision, SESAR is putting in place improvements to the ATM system in a global context. It's a European programme, and we have a European vision which is explained in detail in the European ATM Master Plan. And this is the reference for what we do in SESAR. All of the targets, all of the goals, and all of the key technical and operational innovations that we work on within the research and development programme are all focused on this European ATM Master Plan. We live in an iterative life cycle within the programme. We have the idea of a definition, a development, and a deployment. The SESAR joint undertaking is responsible for this central development aspect, the research and development with our partners of these solutions that improve the ATM system. And we have various phases within that development cycle. We have an industrial research aspect to the programme, often seen as the core part of the programme. And this is where we have the membership of the industries, the ANSPs, the research institutes, etc., working together to deliver SESAR Solutions, which provide step changes in the performance of the ATM system. And I'll come back to what SESAR Solutions are in a moment. We also have two other aspects within that development segment. We have a longer-term view, the exploratory research. We're looking at more innovative aspects, looking beyond the current horizon. What can we look to deliver as options for the future system? Lower levels of TRL, lower levels of maturity, but obviously a greater scope for innovation. And then we have very large-scale demonstrations. This is used where we have a more mature aspect of the research programme, and we want to put it into a real-world environment. We want to have real aircraft on, real operations, flying the solution, to really show that it can deliver benefits. And I'll come to a couple of examples of this type of demonstration as I carry on. The other thing to notice here is that we have this development cycle in the middle, but it feeds out into the deployment on one side, which I think is obvious, as we deliver the solutions, they then roll out into the deployment by the likes of the ANSPs, but also feed back into the definition for refinement of the master plan. As new ideas, new options become available, we refine the master plan to keep it current. So it is always targeting the kind of improvements that we need to see within the European system. So, final bit of general overview here, the SESAR Solutions catalogue. We have become focused in SESAR on delivering what we call SESAR Solutions. They are intended to be tangible aspects of either operational or technical improvement that can deliver a performance benefit and can, in most cases, be considered almost as independent modules that you could go away and implement. And the SESAR Solutions catalogue, which is available on our website, gives you an overview of the 63 solutions that we have already matured to the level of readiness for industrialisation and deployment within the SESAR 1 programme that is about to finish at the end of this year. We continue with this idea of SESAR Solutions going forward into the next SESAR programme, SESAR 2020, that we're beginning the kick-off at the moment. So how do we approach the work that we do in SESAR? Well, the key is we take a flight-centric approach, and this is critical, considering the trajectory of the aircraft, because optimizing this trajectory is how we can deliver benefits across many of these performance areas that you've seen on the previous slide. So this idea of the trajectory, the flight as an object within the idea of air traffic management is critical. But of course, we have to look at the system capabilities and the operational approach to support the optimization of this trajectory, optimization of the flight. We're looking at improvements to automation, adding value to the way that the air traffic controllers work today. Focusing, as I said, on the flight and flow-centric operations, this takes us also at the network level. At network level, we can find a lot of efficiencies. Sharing information is critical. This is, of course, a revolution that we're seeing all around us in our general daily lives, the availability of information. And it's something that air traffic management also needs to embrace. The challenge here is to share the right information with the right stakeholders at the right time to enable everyone to do their job more effectively. Of course, we've got integration of vehicles, and there's a lot of challenges there. Another hot topic everyone talks about is the unmanned airborne systems, drones, if you like. And we have challenges there. But integration of systems, bringing systems together in a more flexible and dynamic way. This idea of virtualization, service support between systems is the way forward. Not necessarily going towards monolithic system development that's very difficult to upgrade, very difficult to evolve, but something that allows us to bring in new capabilities more effectively and more flexibly. So, enabling greener trajectories. Coming a little bit more to the point of today. We have specific SESAR targets related to fuel burn that come from our targets at the SES level, and you see them there. And this relates to both the ground aspect, the en route flying, and takeoff and landing. The targets for noise are not quantized in the same way. However, the European ATM Master Plan explicitly recognizes the importance of noise impact, both as an obstacle to the implementation of ATM, but also as a performance measure to be considered whenever we develop any new capability within the ATM system itself. Now, of course, by its nature, the impact of noise is very much a local issue in terms of the way it impacts people because of some of the issues you've seen from our previous speakers. What we have done within the programme, however, is developed a standardised methodology for assessing the impact of noise. Not only on those solutions and projects that are specifically targeting the environmental and noise aspects, and I'll go into a little bit of detail on those shortly, but for all projects. If we deliver a solution that's targeting increased capacity or increased efficiency, it's still a requirement of each of those solutions to carry out this standardized methodology across a set of performance characteristics to at least demonstrate they're not making things worse, and hopefully we find an improvement. We have a standardized methodology as part of the case for each solution that includes this noise assessment. We've done real operational validations and flight trials, both within the core program itself and within the demonstration activities. And we're looking at how we can maximize some of the aircraft enablers supported by ground infrastructure, and we've already heard a fair bit about the impact of capabilities like GBAS and the benefits that can bring. So we have solutions addressing noise within the program, particularly focusing on approach procedures supported by GBAS. And you've heard, again, it's things we've already heard about a little bit. I'm sure you'll continue to hear a lot more detail on these aspects from the experts over the next 2 days. But we're also looking at overall at optimization of the route network and the way we fly, more direct and free routing, optimization at network level, and even bringing the airport operations into the network plan to reduce the amount of holding and this kind of thing, all of which can improve efficiency and, of course, have a positive impact on the noise footprint. Okay, so to bring a little bit of focus on a few examples, and as I say, I'm sure you're going to hear a lot more detail, and there's a lot of people in the room who are much more expert on these topics than myself. But I take an example here of one of our industrial research programs, so in that core industrial part of the program. This is work that has reached a certain level of maturity, not yet ready for publication as a solution in the most part, and the work will continue in SESAR 2020. But some of the principles here are using the GBAS as an enabler to allow certain aspects that can have a positive effect on the noise impact. The idea of increased glide slopes. We've already heard about initiatives locally here with the move from 3 degrees to 3.2 degrees. But GBAS gives us the opportunity, particularly if we can move towards precision approach support for GBAS, to actually be more dynamic and even take that increased glide slopes further. We can be more flexible in terms of multiple runway aiming points, double slope approaches, a whole set of measures that could have positive benefits in terms of noise impact. One that's a little bit more close to today, one that I think we've got more faith in being able to introduce in the short term, is the idea of curved segments which then intersect the landing system, whether that is a traditional ILS or a GNSS-based landing system for precision approaches. And this is work that's been carried out with a number of industrial partners that you see on the screen there, including DFS, and across locations across Europe. This is work that we have taken to a certain level of maturity, but there remains work to be done, particularly on the more dynamic aspects of the approach procedures. I come on to a couple of specific demonstration activities now. This is where we take the more mature solutions closer to implementation by putting them into a real environment with many real aircraft implementing the solution. This is one of our most successful demonstration projects, Augmented Approaches to Land, and I believe you will get a much more thorough briefing on this project tomorrow. So I would very much encourage you to make sure you get up early enough. I think it's the first presentation tomorrow. But this is very much focused on these aspects of curved RMP segments that can be used to improve the noise footprint of your approaches. It also looks at the notion of using satellite-based augmentation in cases where there is not necessarily a ground infrastructure required to support GBAS, but you can still have great improvements in things like regional and more remote, smaller airfields, using a combination of space-based augmentation and vision systems. You see there that Frankfurt was one of the key locations for the demonstration flights that took place in this demonstration, and the conclusions have certainly been positive with regard to the noise benefits that these new procedures can bring. So I hope you look forward to hearing more about that tomorrow. A second demonstration project that we also conducted within the SESAR 1 program is called RISE. This is specifically related to RMP implementation, and again demonstrated quite a number of flights across a wider spread of locations that you see there on the screen, and looking at various approach procedures relating to RMP and RNAV that you see there. A portion of this demonstration was looking at RMP AR, authorization required, and we know that there are challenges with regard to this, and it is, let's say, a little bit constraining in terms of how far we can deliver benefits on this because of some of the implications it has in implementation. However, it also included very much solutions that are ready for deployment in terms of RMP1 to ILS transitions and the way these can be used to improve approach procedures. Again, the conclusions that came out of this demonstration from this significant number of flights is that it is possible to avoid sensitive zones around airports in terms of noise mitigation, and of course you can provide efficiency and fuel savings, therefore emission savings, because of more effective shorter tracks and miles saved. It's also the ability to enable continuous descent operations. I hesitate to talk about that too much because I'm not sure I want to be asked to define what it is. Okay, I talked a little bit about the fact we have a standard noise impact assessment methodology. This is something that is a required part of all of the solutions that we deliver within SESAR. So even those that are not targeting environmental or noise aspects have to take a look at what the impact of their solution would be using this assessment methodology as part of their case of material that supports the solution itself, along with other aspects such as safety cases, security cases, etc. And so you see a little bit of detail here on the methodology and assessment that has been applied across all of the SESAR solutions that have been published. Okay, going forward, SESAR 2020. So as I explained at the beginning, we are about to embark on the second SESAR program. The current program, SESAR 1, has run from 2009 and will close out in the coming days. It has to be finished by the end of the year. And the solutions are captured within the solution pack that I've talked about. But we continue. The second program is already up and running. We're beginning the projects of the main industrial part of that program already. The exploratory research is working, and the demonstration activities are starting to ramp up as well. Certain aspects of the work that was done within SESAR 1 will be taken further within SESAR 2020. In particular, the enhanced arrival procedures enabled by GBAS, where we look to take some of those capabilities, the curved approaches, the flexible glide slope and the displaced thresholds to maturity, such that when we deliver within SESAR 2020 in the next 3 or 4 years, those become available for deployment. We're looking at specifically terminal area operations as well, use of curved segments to optimize procedures. I mentioned rotorcraft operations there because, again, we're looking at the support of these satellite-based navigation capabilities, GBAS and SBAS, to enable rotorcraft and general aviation operations in non-interfering ways, but also in ways that are optimized in terms of noise impact. Arrival and departure management is also potentially impacting here, where we look to extending the horizon of arrival management to optimize the sequencing as early as possible. This can allow for more efficient approaches, enabling things like continuous descent approaches in certain circumstances. And then the whole network planning and the role of the airport in that continues to be worked, where we look at that total airport performance management, how that links with our network performance, and how that itself can be then used to plan more strategically to allow more efficient and more predictability about the trajectories that we're managing in the ATM system. Finally, we have exploratory research and demonstration activities within the new program that are looking at issues such as advanced methodologies, the idea of full trajectory operations, defining the trajectory in advance in the most efficient and effective way, and enabling that as much as we can without what some see as interference from the ATC system. How can we enable an aircraft to fly in the best way possible? These are longer term ideas, things that we're looking at to bring forward in maturity, but they are solutions that we can still look at within the timeframes of the ATM master plan. And we continue to demonstrate solutions. There will be more demonstrations with more real flights showing that these solutions, based on capabilities like GBAS and SBAS, can deliver benefits across the full set of performance criteria, including environment and noise specifically. And these things can come soon because we're doing this joined-up research within the SESAR program. So I come back to the final slide, which is the same as my first slide, but it gives us this vision. The fact that we work within the frame of this master plan, a master plan that's agreed by all of the stakeholders as setting the way forward as to what we're trying to achieve. It sets the basis for performance goals. It sets the basis for the kind of solutions we need to deliver. It gives us an idea of technology roadmaps. What kind of technologies can enable these performance benefits? And we deliver these in the form of solutions in that catalogue. But we do this in a frame of a global ATM system, a global ATC system. And in particular, the airlines are the ones who have to operate in this global system. And we need to have harmonised solutions. So we work in close cooperation with the FAA and their next-gen programme. And we work very closely, hand in hand with ICAO. We contribute to the Global Air Navigation Plan. And the ATM Master Plan and the SESAR work is seen as a very strong input to this work, along with our colleagues in the US and across the rest of the world, such that we have a sustainable view of the way forward for ATM at the global level. So that is the SESAR vision. A little bit on the specific work that we're doing today that impacts on noise. You'll hear more from the experts over the coming days with a lot more detail on the specific projects and demonstrations that we're conducting through SESAR. And they're far more expert on these matters than myself. But I hope this has been useful as an overarching vision as to where it fits within the future programme. Thank you very much.
So, thank you for presentation, Mr. Bowen. Gibt es Fragen an Herrn Bowen?
Thank you very much, Mr. Bowen, for
Zu
your
dem Programm
presentation.
SESAR.
Are there any
Da
questions
hinten.
on SESAR?
I haven't got my interpretation thing, so I may
Yes.
struggle with German.
Mein Name ist Gabriele Franz.
My name is Gabriele Franz.
Sie wollen das Flight-Management verbessern und betrachten dabei
My name is Gabriele
verschiedene
Franz. You
Aspekte,
would like to improve
unter anderem
flight
den
management,
Umweltaspekt,
and you
und Sie
talked about
haben auf einer
the
Folie
impact on the
natürlich
environment,
darauf hingewiesen,
and on
dass
one of
sich
your slides
Lärmminderung und
you said that
Schallschutzreduzierung,
reducing
in manchen
noise and
Fällen im Wege stehen,
emissions
also nicht in die richtige
are
Richtung gehen.
sometimes not
Ich
compatible.
will in dieselbe Richtung gehen. Ich habe jetzt eine ganz konkrete Frage.
Now I have a very specific question on the Rhine-Main area. And maybe my question should have been asked to the previous speakers. We have a specific trajectory, the south route, where the reduction of noise and reduction of emissions are not compatible. Now, I would like to ask the previous speakers whether SESAR is helpful, whether the guidelines developed by SESAR can help, or is it something you have already taken into account when the trajectory or the route was developed? We have Mr. Biestmann sitting here, and maybe he can answer directly. I'll try to give you an answer to that question. In the SESAR deployment plan, in the ATM master plan, there is no measure which is focusing on the procedures for starting off. In SESAR 688, in the first part, we had some simulations on descent procedures. But when it comes to starting off, we're rather focusing on avionics. So when it comes to takeoff, then we are trying to reproduce trajectories But when it comes to our equipment, we are still restricted, so we're not able to give that much precision to it. So at the moment, SESAR, and I think in your presentation, Mr. Bowen, it was the third slide where you talked about research. Well, we are not able to implement specific deployment parts.
Okay. Weitere Fragen?
Further questions, please.
Hier hinten.
We have someone in the back.
My name is Regine Barth. I'm working for the Hessian Ministry of Transport, and we are the authority which is responsible for the license to operate for the airport, and I'm responsible for the noise abatement for the Frankfurt airport. So that's a big issue, of course, in this region, you might know. You have talked about GBAS, and Frankfurt Airport and DFS have been one of the pioneers in Europe to implement this here, but we unfortunately see still very little flights using it because many of the aircraft is not capable or does not have the license to use it. And it is partly understandable because there is no business case for the airlines to really use it. And we have, as in many cases, when we talk about modern systems of using procedures, what we call in German the hen and egg problem. If there are no procedures that you can use, there is no incentive for the airlines to really do it. No noise benefits, no more efficient fuel and stuff like that. And on the other hand, if there are no aircraft who can use it, we cannot have the procedures because we have to make sure that all aircraft can use it. So one of the big questions is how fast can the ICAO really develop the criteria and the regulatory framework to make sure that it can be used. And we know that there have been some delays on that level, especially if we talk about Cut 2 and 3 conditions. So my question to you is, in how far does and can SESAR influence the speed and of course also the outcome of what happens on the international level? Because as you have said, and that's absolutely, I back that, it is a local problem that we have to manage locally, but of course we are dependent on frameworks which are globally and partly European framework, and it is very hard from the local level to really influence that. So from our point of view, it would be really, research is the one thing, but the other thing is to make sure that we can use it and that it can be implemented as soon as possible.
Thank you for the question. I think it's a very good point. We are a research and development program, and we develop solutions to a point where we say these are ready, but of course that's not the end of the story. Actually getting those put into deployment requires us to continue to engage to support and enable the various measures that need to be in place, such as the ICAO regulations, such as the industry standards that are needed. All of this is part of that jigsaw that builds towards deployment. Of course, we're absolutely committed to doing what we can as the R&D program to bring some positive momentum to these steps. Of course, we're not directly responsible, and I know you're going to hear from ICAO following myself, and they'll certainly have their own views on this. But as a research program, what can we do? Well, we have a very clear view in terms of bringing the material that we have produced as part of the research program. So this makes up the solution pack. That includes work on the validation results as well as technical specifications, etc. A lot of mature material there that we make available into the standardization and regulation domains in order to put some impetus, some momentum behind that process. So we work very closely with the industry standards bodies such as EUROCAI and RTCA, making the SESAR material available that will form the basis for the technical standards needed as means of compliance for these aspects. But then we also work with ICANA, not only at the planning level in terms of the GAMP, etc., but also at panel level, where they're working on both procedure and technical provisions, making SESAR material available, which we hope can, again, move these things forward faster than we're traditionally used to expecting this material to be developed. In summary, while it is to some extent not our direct responsibility, we do take it very seriously. We coordinate very strongly with these bodies, and we make sure that the material we provide is targeting being fit for purpose for those next steps of regulation, standardization, industrialization and deployment. One final word on deployment, and many of you will be aware of this. We have a sister organization, the SESAR Deployment Manager, which is responsible for implementing certain SESAR solutions that have been packaged within a first regulation published by the Commission called the PCP. And there are RMP aspects within that first regulation. And they are carrying out a number of deployment projects with ANSPs, industries, airlines, to progress with both the technical capabilities and the operational implementation of certain aspects of SESAR Solutions that, as I say, already includes RMP elements. And there will be more initiatives like this to drive SESAR deployment as we go forward. So I know it's not a perfect answer, but I think we're doing our best to push the momentum from research and development through to those next steps and try and help make it happen.
Okay, vielen Dank. Noch eine Frage?
Thank you very much for that answer. We have time for one more question. And this question is off mic. I can't hear her. So let me start again. When it comes to GBAS, research focused on descent procedures, but when it comes to takeoff, you seem to focus on other factors when it comes to active noise abatement. How comes?
Mr. Bowen, can you answer?
It's a good question. I think certainly when it comes to arrivals, the constraint was very much seen as being able to provide the appropriate level of navigation capability to support precision approaches. And this is, of course, based on the fact that we're all used to the capability that is today provided in most parts by ILS, right down to the Cat 3 operations. And the need to provide the level of precision for those precision approaches really drove the technical development of GBAS in terms of supporting the descent operations. When it comes to departures, I think, of course, there are technical requirements on the navigation system, and you'll look at you know, what the appropriate RNP level is for those procedures. And they tend to be a little bit less constraining the descent operations. Where we find, I think, more challenges with regard to departures are twofold. Technically, it's very interesting to look at the way different aircraft and their flight management systems work, and I think that's something that's certainly become apparent as we've gone deeper into this work, that there is a great deal of specificity in the workings of the FMS and how ascent profiles can be programmed. The other part, and it was touched briefly on the previous presenters, is the kind of airspace design aspect when it comes to departing routes and arriving routes, particularly when you're trying to not constrain the routes, you're trying to allow flexibility in terms of continuous descent or continuous climb operations. And this has impact on airspace design when you have crossing points between the two. And so generally the view on those aspects has been focused on this operational aspect with regard to the airport airspace design and the way that we can manage uncertainty at crossing points. And of course some of the flight profile aspects of the aircraft itself. I think ultimately we know that the GBAS developments, if they are capable to support precision approaches, will have the necessary navigation capabilities to support the departure operations, and we focus on the operational aspects of the departures because we see that as the key blocking point.
Okay, vielen Dank, Mr. Bowen, für den Vortrag und die